Today we will look at N708, paper 3, variant 1, economics. Let's look at the first question. What does the marginal utility diagram show? Marginal utility diagram. Now we know that this graph shows utility, total utility, and beneath it we can draw the marginal utility graph. So MU. So as consumption of a good increases from 1, 2, 3, 4 units, total satisfaction keeps on increasing, reaches a maximum, then starts to decrease. So this is the total utility graph. Now let's assume this is 5, this is 6. So our marginal utility will start from 0, 1, 2, 3, 4, 5, and 6. So when the total utility is at its maximum, clearly we are consuming 3 units there. However, we also know that when total utility is at its maximum, marginal utility will be a 0. As total utility increases, marginal utility decreases. Therefore, we have a graph that way, passes through 3 here at 0, then becomes negative. So that is marginal utility. So here the marginal utility is 0, here is negative, here is positive. Total utility is positive throughout, even though beyond the point where the marginal utility is 0, the total utility will start decreasing. So our question was, what does the marginal utility diagram show? Total utility becomes negative if the quantity consumed increases from Y to Z. Let's check. When quantity consumed increases from Y to Z, total utility, the choice was saying total utility will become negative. Total utility does not become negative. That is this point where total utility is still positive even though decreasing. So A is wrong. So total utility decreases if the quantity consumed increases from X to Y. Let's check. When quantity consumed increases from X to Y, that is this region here. So total utility is increasing. However, the choice is saying total utility decreases if the quantity consumed increases from X to Y. Therefore, that choice is wrong. Let's look at choice C. Total utility decreases if the quantity consumed increases from Y to Z. When quantity consumed increases from here to here, total utility decreases. So that is this region between this and this. So it's true, total utility is decreasing. So that is true. Then total utility is maximized at X. Let's check. So X is here, which is around here. So total utility is only maximized at this point, that is point Y, which is 3 units. Therefore, choice D is out. Let's move on to the second question. The initial allocation of goods between 3 consumers is shown. So consumer 1, 2 units, consumer 2, 5, consumer 3, 10, then the total is 17. Which row shows the Pareto improvement, the allocation of resources? Again, we have to draw the graph for Pareto. Now, clearly, we have our people. So this is good A, for instance, and this is good B. Now, for us to be Pareto efficient, we must be operating along PC curve. So let's assume we are at point X, that is Pareto efficient, meaning we cannot make one better off without making the other worse off. We cannot increase production of good A without sacrificing some units of good B if we are Pareto efficient. Now here we are looking at Pareto improvement, meaning we are Pareto inefficient, meaning we are operating somewhere here. Let's call this point K. Let's call this point Why? Now, for us to obtain Pareto improvement, and that means we have to move this way. That meaning we can increase production of good A without sacrificing any unit of good B. We can also move this way, meaning we can increase production of good B without sacrificing any unit of good A. That is Pareto improvement. So, in a nutshell, what we are trying to say is that we can make either of these, any of these three consumers better off without making any of them worse off. So, in that case, let's look at choice A. Consumer one, still 2 units. Consumer two, five as uh, initially. Consumer three, now we are making this consumer better off through one extra unit, so getting 11, but then we are not making consumer 1 and 2 worse off. Therefore, this is a case of Pareto improvement. So let's look at B. B, we are making consumer 1 better off. We are making consumer 2, there is no change. Consumer 3, we are making uh, this person worse off. Therefore, because of this, that is out. Choice C, we are making consumer 1 better off. That is okay. Consumer 2, we are making the consumer worse off. Consumer 3, no change. Therefore, this is making it wrong. If you look at the fourth choice, consumer 1, we are making him or her better off. The second consumer better off, while making the third consumer worse off. So this is making the choice to be wrong. Therefore, the right choice here will be choice A. And question 1, the choice was C. Okay. Question 3. Which assumption in relation to an indifference curve, indifference theory diagram is not correct? So that means 3 of them are correct. So we know very well an indifference curve will look this way. So this is good A and this is good B. So in this case, we have our indifference curve that way, I. Now, we are saying the consumer's income may change. Consumer's income, yes, may change, and if the consumer's income changes, then the consumer may move to a higher or lower indifference curve. So that assumption is correct. B is saying the consumer may change their satisfaction maximizing objective. This is not true because the consumer along an indifference curve will only substitute, will only substitute one good for the other. It's not about setting objectives. C, the consumer may change their taste and preference. Yes, this is what we are calling the marginal rate of substitution. So for instance, if the consumer was operating at point X, whereby the consumer was consuming this combination of the goods, let's say X1 of good A and Y1 of good B. Now, the consumer can prefer good A to good B, meaning he or she can move along the difference curve and consume extra units of good A as he or she sacrifices some units of good B. So that is the change in taste and preference. Indeed, the relative prices of the product may change. Yes, that is true. If the relative prices of the product changes, then that means the indifference curve will either shift upward or downward depending on the change. For instance, a decrease in price of good A will pivot the budget line. So assuming this was our budget line and the price of good A decreases, for example, that will pivot the budget line outward and it will mean a shift outward, outward of the indifference curve. Hence, the consumer will be able to uh, operate on a higher indifference curve. So therefore, B is not correct. Question number 4. Which type of efficiency is shown by the shift from long run average cost curve 1 to long run average cost curve 2? Now, we know well that if this is output and this is average cost, in the long run, firms in imperfect markets, to be precise, oligopolies and monopoly, are able to operate along the average cost curve at the point where average cost is decreasing as output is increasing. This is because the firms are both allocatively and productively inefficient. So because of the abnormal profits that they make, the firms are able to reinvest that profit in new technologies through research and development. Hence, they're able to push the average cost curve down but still remain inefficient. Therefore, this is what we're calling dynamic efficiency. So this is dynamic efficiency. Allocative efficiency occurs where price is equal to marginal cost. This is not the scenario in the graph. Pareto efficiency occurs along a PPC this way. So if this is, let's say, good A and this is good B, then if you're operating along the PPC, anywhere along the PPC, we operate efficient. Productive efficiency occurs when we are producing output uh, while operating at the lowest point of the long run average cost curve. So this point. So that will be productive efficiency for a farm. For the economy, anywhere along the PPC will be productively efficient. So on to question 5. A farm wishes to maximize its revenue. Which condition must be met to achieve this goal? So let's again quickly check. Now if we have this graph here, let's call this average revenue curve. This is output. This is our cost stroke revenue. This is marginal revenue curve. And we have this as our average cost curve. AC. This is our marginal cost curve. Where the marginal cost curve meets marginal revenue curve, the farm will be profit maximizing. So at this point, output Q, the farm is a profit maximizer. So profit maximizing will be where MC is equal to MR. So this is profit maximization. Where average cost meets average revenue, here, let's call it Q1, the farm will be maximizing sales. So sales maximization here. Where the marginal revenue is equal to 0, let's call this output Q2, the farm will be maximizing sales revenue or total revenue. Where the marginal cost meets the average cost, let's call this output Q3, the farm will be allocatively efficient. Sorry, will be productively efficient. Where MC is equal to AR, that is this output, let's call it Q4, the farm will be productively efficient. So this is productive efficiency, and at Q3, the farm will be allocatively efficient. So which condition must be met to achieve the goal of maximizing revenue? So it will be where marginal revenue is equal to 0. So the answer is D there.